You're welcome. We have discussed quite a number of methods that we can use to solve quadratic equations in mathematics. And if I can remind you from the previous sessions that we have had, we talked about the factorization method, we discussed completing squares, we also discussed the method of using the quadratic formula. In this session, we are going to discuss the fourth method that we are supposed to use to solve quadratic equations, and this one is the graphical method. My name is Javira to take you through. Now, before we start doing analysis on how we should use this method, please make sure that you know how to properly use the Cartesian plane. That is, you should be knowing how to plot on the x-axis and the y-axis, and two, you should be able to determine the appropriate scale of the given data. Okay. If we are given an equation like y is equal to ax squared plus bx plus c, we can plot this equation on a Cartesian plane. But the question is, how do we do this? Now, if we look at this equation given to us, y is a function of x. This means that any value assigned to x will be having a corresponding value for y. In many cases, they will give us a range within which x values lie. Now, if when we are plotting any quadratic function, we should expect the following. Number one, we should expect either to get a curve that is U-shaped, or we can get a curve that is N-shaped, as far as our level here is concerned. Now, what determines the U-shape and what determines the N-shape? We go back to our function y is equal to ax squared plus bx plus c. We make analysis on the coefficient of x squared. When the coefficient of x squared is positive, we should always expect to get a U-shaped curve. And in mathematics, we call this one a minimum curve. When the coefficient of x squared is negative, we should expect to get an N-shaped curve. Or sometimes we say this one is mountain-shaped. And we get that one when the coefficient of x squared, the one that we call the a, is less than 0. And we get the minimum when the coefficient is greater than 0. We can have an example. If we are given an equation that is having real values, now not having the unknowns, we don't have the a, we don't have the b, we don't have the c as unknowns, but now we are putting in real numbers. Suppose we have an equation like y is equal to 2x squared plus 6x minus 8. How do we tell whether this one will give us a minimum curve or a maximum curve? We look at the coefficient of x squared. In this case, the coefficient of x squared is 2. And 2 is greater than 0. Remember we said that when the coefficient of x is greater than 0, we expect to get a U-shaped curve. Or we call this one a vary-shaped. Or we can call it the minimum quadratic curve. The other example can be y is equal to negative x squared plus x minus 5. Still, before we go into plotting and drawing the curve, we can still tell whether this will be a minimum or a maximum by checking the coefficient. In the second example, the coefficient of x squared is negative, and we know that negative 1 is less than 0. Therefore, our second example will give us a mountain-shaped curve or an N-shaped curve, or we call it a maximum curve. In summary, we have said that whenever we are going to use the graphical method to solve any quadratic equation, we take note of the following. Number one, we should be able to give an appropriate scale if it is not defined for us. Number two, we should be able to plot on a Cartesian plane. Number three, we should be able to tell whether the given quadratic will give us a minimum curve or a maximum curve. In our next session, we are going to be talking about how to generate a table when we are looking for the coordinates to plot in order to get a quadratic curve. Thank you.